on Form 4, Chapter 4, Form 4, Physics, Chapter 1, Part 2. Chapter 1, Part 2. This video, we will start out with types of quantities. Scalar quantities is a revision from my first video, scalar and vector quantities, whereby quantities are those measurable physical quantities. You're able to use a meter ruler depending on how much of the accuracy you want, measuring tape or meter ruler. For long distance, you will use measuring tape. For shorter distance, you use a meter ruler or centimeter ruler, depending on what's the quantity of your object. So, in a vector and scalar quantity, then followed by how we're going to make use of our positive error, types of error, and negative error for Vernier caliper, micrometer screw gauge, and then after that, I will be doing nature of measurement. You have errors in types of errors, actually. Errors in measurement. We'll talk about zero error, or we'll talk about systematic error and random errors. And then followed by consistency, accuracy, and sensitivity, meaning a definition of how you define consistency, accuracy. I think I would expect my viewer to copy or perhaps make your own notes. You can't just watch this video and you thought you will know it. You might want to summarize from what you have seen here, or you want to copy what I've gone through here. Then once I've gone through that, then the last thing would be the type of graphs, analyzing graphs. Well, of course, this is a summary, and it helps you actually for your reading, because you need to read your reference. Okay, that will be the last part. And there are some experiments that I will not be able to cover in this video, that I really need if you want to excel in physics, you really need to read. Well, except that you want just to pass, then maybe my video will help you just to pass. Your effort to read is important. So let's start out with our first part, scalar vector quantities. By now, you should be quite clear of difference between what are the quantities, the base quantity and derived quantities. Out of those quantities, some will be called scalar, whereby you only have just a number, whereas the another will be called the vector quantities. There are two, just like what you have learned in your maths, scalar quantities and vector quantities. So what's scalar quantities? So the terms of rule, get to know scalar quantities. Scalar would means just magnitude, only magnitude, only the size of magnitude. What does it mean? It means the number is only just a number. It doesn't tell you of which direction it's going. Okay? Say for example, length. You have 5 meters. So you just know the magnitude. It's just 5 meters. You have no idea which direction it is going 5 meters. To the east or to the west 5 meters. You have no idea. So length is actually a scalar quantity. Another example would be time. 6 seconds. You have no idea which direction. There's no way to tell which direction. Or perhaps frequency. Right? 6 hertz. You have no idea which direction this is going. Mass, perhaps. Yeah. So these are the 10 kg. Yeah. These are the example. Yeah. They are a lot small. Yeah. Says not limited to only base quantity. Say for example energy. Energy as in 100 joule. Right. Special unit. Those are called special unit. It's also a scalar quantity. You have no idea which way is going. Yeah. It's just the magnitude. Likewise, for vector quantities, maybe I use another color. Vector, it has magnitude, the number tells you of magnitude, and direction. Let me give you an example. Force, perhaps. Force, F. Oh, is I'm supposed to cover this. Okay, no. I think our force says 10 Newton. So 10 Newton is also a special unit, where force equals to ma, mass times acceleration, meaning the force is maybe 10 Newton to the right, 10 Newton. Okay, force. And maybe acceleration is also acceleration. You have 6 meters per second going downwards, or accelerating to the right or to the left. Velocity have 10 meters per second, meaning if you were to be a velocity, meaning you have direction. Likewise, you have only speed. Yeah, speed, that will be a scalar. Speed unit is u, maybe a 10 meter per second. Whereas if it were to be velocity, meaning it's telling direction. Velocity, small v. Yeah, that's the difference. Small v is velocity, small u is speed, meaning they tell you of how it change over time. How does the length change over time? Yeah. So that's the difference. Any number that tells you of a direction and also the magnitude, then that's vector quantities. I think I doesn't need to go deep down into it. Yeah. You may do some reading, then you have some idea what's happening, but tells you how it goes. So, meter ruler, measuring tapes, meter ruler, those are something that you are quite familiar with. A meter ruler normally will be in a meter, 1 meter, 100 centimeter. Meter ruler is accuracy to few 1 mm perhaps accuracy. So that's not some big deal. You may go through. What does it mean by that? Next part, that would be vernier caliper. Now, what's so great about vernier caliper is something that you have never seen actually. Not many people would have seen it in the classroom or in a stationery shop, because normally we'll see a meter ruler. You're able to see it, or you have even used it. Yeah. Likewise, for vernier caliper, you want to get a look at it, because a vernier caliper, they will normally ask you what's is for. Normally you will use to measure the inner diameter, inner diameter, or perhaps the outer diameter of an object. Not to forget, also the depth of an object by using the tail. Yeah, the depth, how deep. Yeah, or the depth. Okay, so how does it look like, the construction of the vernier caliper? I'm sure you were able to see it I've seen it in textbook. But what I want to do is something, a fact. Yeah, the minimum, the smallest possible, or you call it as an accuracy. Accuracy. I know this is something new to you. This term is something new term. You might not get used to it at the moment, but you just know it. The accuracy for a vernier caliper is 0.01. Okay, 0.01 centimeter. So the smallest value, the smallest magnitude that you could measure is 0.01 centimeter. I want to stress it, it is centimeter, 0.01 centimeter, the accuracy, the smallest possible value you measure, the smallest object you may measure. It means accuracy is up to 0.01 centimeter. So if you go through your book, yeah, so you were able to find out the inner jaw, the outer jaw, the tail. Those are for the inner diameter, outer diameter. Because what happens is, if you're given an object like a cylinder, you think of a cylinder or a tube, okay? A tube, okay? A tube of a very thick wall, okay? Of a very thick wall, okay? Then how good to measure, okay? So there are two things. One is you measure the outer diameter. So what is outer diameter? Outer diameter is the length from here up to here. Those are called the outer diameter. You need to find out what's this length. Inner diameter will be the one here to here. This is the inner diameter. But of course for 3D, then it's supposed to have dotted line, right? Depending on how deep is it. So the depth, okay? The depth of it, you make use of the tail, okay? To measure, okay? What's the depth here to here? Okay, the depth, okay, you're able to measure it by using the Werner caliper. Then, if you are using it, then you will have some problems. Sometimes after extensive use, wear and tear perhaps, then you tend to have error. Okay, so we are not into the types of error yet, but what are the errors possibly? Yeah, you have positive error. I'm going to spell the whole word here. Okay. Positive error. Now, what does it mean positive error? Positive error is there are, in the scale of the Werner caliper, there are main scale and also the vernier scale. Okay, and vernier scale is 0.1 mm short. So, what happens when there's no object? You try to close the gap. Okay, the major scale 0, and maybe here is 1, and there are maybe 5, 1, 2, 3, 4, 1, 2, 3, 4. What happened? You have positive error. The vernier scale fail. The lower part scale of it fail. The 0 fail to be at 0. Maybe it stops somewhere here. Okay, here is 0, and then okay, here. Okay, so what happened? If you try to close it, but it doesn't close well, it starts out with this. So what happened? You have positive error. So if you have positive error, what you do is you look for the notch. Okay, maybe here. They're close to each other. I mean, the top one and the major scale and the vernier scale coincide. Okay, you look at this notch. How many? You look at the vernier scale. How many notches are there? If 1, 2, 3. So what happened? You have at 0 error, positive 0 error. So therefore, maybe 1, 2, 3. Therefore, your positive error is equals to 3, 0.03 centimeter. You need to add this value. Once you read your reading, get your reading, you need to plus. You need to subtract this value. Okay. Okay. So next we have 0 error, no error. Okay, meaning 0 error. What happens? You have 0 error. 0 error meaning it means when the major scale close at the vernier scale. So this is 0, and this is the vernier scale. Okay, so 0 when they coincide with each other. So this is 0 error. Whereas in this case, maybe highlight it. This case, the 0 doesn't close, doesn't coincide with each other. So that's a positive error to the right. Okay. So this one, you just read the reading, get the reading, and there's no error. Okay, the line with the 0 mark, with the scale. Okay, so positive, negative, and first 0, then the next one will be called the negative. Negative error, however, for the Wiener scale, 0, the major scale, the Wiener scale is, the 0 is somewhere behind it, 0. Then, oh, that's a little bit tricky because now maybe the 10 is somewhere here. Okay, then, 1, 2, then what you do is you look for the one on the right hand side. Okay, maybe here is 1, then maybe you have 1, not really. Okay, let me do it properly so that you can have some idea what's happening. Okay, so this is my 1, and you have 1, try not 2, okay, 2, okay, so this is, you look for the right hand side, how many notch, okay, let's say 1, 2, maybe here, the third one, okay, the third one, the major scale, coincide with the first one over the right hand side, meaning here to here. So see, this is where they coincide. Okay, if that's the case, what we do, therefore there are how many over the right hand side? There are 2, right? So there are, oh yeah, before we go to 10, so the 1 raised to 10 is 1, right? Here to here is 1 notch in the Wiener scale. So here to here is 1, right? 0.01 centimeter. So therefore, your 0 error, your negative error, is actually negative 0.01 centimeter. So in your reading, be sure, yeah, you plus this value, because in order to get rid of the error, you need to subtract the error. So for this case, you need to subtract negative error, so you need to plus this value. For positive error, you need to subtract this value. Right? Subtract the error. What does it mean by that? Okay, says your final reading. Let's say your final reading is 2.76 centimeter. And if were to be an error, so you need to subtract error. Depending on what error, if you have positive error, therefore you have 2.76 centimeter, subtract a positive error. Positive error, this is positive, right? So it's positive 0.03 centimeter. So you subtract them, you get a value 2.73 centimeter. If it were to be a negative error, the rule would be the original, the final reading, subtract error. The error is negative 0.01 centimeter. So therefore, it will be 2.77 centimeter. The thumbs up rule is always you need to subtract the error. You need to subtract an error depending on whether this is a positive or negative. Yeah. If you have a positive error, then you need to subtract that error. If it were to be negative error, then meaning you need to plus the value. But the thumbs up rule would be for positive, you look for those on the left hand side. How many where the Wiener, where is the Wiener coincide with the major on the left hand side? Okay, where if it were to be negative error, meaning over the right hand side, where the Wiener scale coincide with the major scale. Yeah. How do you determine positive error? Positive error when the 0 for Wiener is on the right hand side. Like in the Cartesian, or anything on the right hand side is positive. So therefore, the Wiener on the right hand side is a positive error. Likewise, negative, the Wiener scale is on the left hand side of the major scale. So therefore, it's a negative error. So that's actually how you normally read Wiener caliper, right? So next, what you need to do is to pause this video. I want you to pause this video. Go look for any exercise book, workbook that emphasize on Wiener caliper. You need to try. You need to at least have 2 2 to 3 workbook on it and try 5 questions. How do you read when a caliper? Okay, so once you have get it done already, you pause. You may resume this video, and you may want to, by using the same manner, you may go through something called micrometer screw gauge. That will normally measure actually the diameter. You have a main scale and a timber scale. Main scale, the one with timber is the one the handle. You need to close it gently until you hear the click sound. Okay. Normally you measure diameter of a wire, a thickness, because the accuracy is up to 0.01 mm. So that's the difference. Yeah, micrometer screw gauge is 0.01 mm, whereas the vernier is 0.01 centimeter. Okay, so how do you normally read that? I think you may go through the books. How to do it is quite straightforward. They will have a positive error and negative error. So by using what you have learned in vernier caliper, then the concept is the timber scale. Yeah, make one round, you have about 50 notch. Not about, it's exactly. Yeah, so that's an increment for 0. It's 1 mm increment. So you divide them, you get 0.01 mm. You read through the books on how to do it, and then try for 5 to 10 questions. Then I'm sure you can handle micrometer gauge. Yeah, I try not to include everything, because otherwise you will not read your textbook, or perhaps not read your reference book. Yeah, the main purpose is for you to read so that you will be able to prepare you. Sometimes later in your degree, you will be able to make your own notes. Okay. Next would be errors in measurement. For errors in measurement, types of errors in measurement, or you call uncertainties. Yeah, there are actually 2 types. One is called systematic error, and the other is called random error. Okay. For systematic errors, something that they say is a cumulative error, meaning it's something that you will be able to correct it. Yeah, you're able to correct it easily, like those positive and negative error. You're able to overcome it. Yeah, because it's caused by incorrect calibration. Yeah, you mean the 0 is not at the main scale. It doesn't show of a 0. Okay, it's normally occur. Yeah, if you continue to use the measurement instrument the same way. Okay, so what's systematic error? Yeah, like what I have shown you earlier. Systematic error example will be like 0 error. Yeah, you can really actually you know how to reduce it by position the 0 back to the original. Okay, 0 error would be the measurement instrument does not start from 0. Like positive 0 and negative 0. I've shown you earlier, like in microscope. in a linear caliper, right? So, like the next one we call random error. Now, random error, there are variety of reasons, many reasons. Okay, there are many reasons. Okay, um, personal error. First one, maybe personal. What is personal error? Personal error, like for example, the parallax error. You have, I hope you have heard of this word, LLAX, parallax error, where the position of your eye is not at the zero, or perhaps in the meniscus, in the water, perhaps in a cylinder tube. The position of your eye are supposed to be perpendicular, yeah, to the lower curve of it, where it curve. Okay, personal error, or perhaps natural error caused by wind blow. Yeah, your natural errors, changes in wind, maybe temperature, magnetic field, or gravity, in the experiment process. It interferes. Magnetic field interferes with your compass. Your magnetic field interferes with your electronic gadgets. Okay, or perhaps wrong techniques of the measurement. Okay, um, your micrometer screw gauge, you turn it too hard, and the object is soft. Therefore, the timber will tend to exert a very huge pressure, huge enough to make a dent into your object. Therefore, the measurement comes out. It's not the right reading. So the use of wrong technique, okay, you overdo it. Yeah, you apply excess pressure. Okay, so how can you reduce it? Can you reduce it? Yes. Random error, you reduce by minimize or reduce, taking several times, or the average by average. By average the reading, meaning you done a few more times. Okay. So as I said earlier, what's parallax error is the position of eye is supposed to be tangent to it, and you have the potentiometer or the voltmeter that is a mirror. Okay, underneath the needle, make sure the position of the needle is directly perpendicular. You do not see the image or the they call it anti-parallax mirror. Those are to reduce random error. Okay. I think that's basically all about it. The last part of it would be consistency and accuracy. Okay, for consistency and accuracy would be something that you need to really the comparison, consistency, accuracy. Sensitivity is about how small, the smallest possible value that the ruler will be able to measure. Okay, you may read through it in your text, from your text. A summary for it would be the consistency. Consistent. What does it mean consistent by words? Consistent, it means it's always occur at the same place. Okay, say I'm playing duck. Okay, duck game. Okay, this is the bullseye. You are shooting at it. What happened? You always shoot at certain places. Want to always the same place. Now this is a very consistent, but it is not accurate at all, because you are supposed to reach here, but it always reach here. So it's either caused by wind blow, or it's either caused by the position of the gun. Yeah, it's very consistent, but it's not accurate. Right? Then how about accuracy? But to me, this is consistent but not accurate. accurate means this same case above. Your target is very accurate, meaning here, 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 maybe here. This is very accurate. It reached the center. Unfortunately, it is accurate, but not consistent, but inconsistent. Okay. So how do you get accurate and consistent? Then there will be you are supposed to have 1, 2, 3, 4. It's spread out along the target, then it will be very consistent and very accurate. Yeah, not accurate, not consistent, meaning it's randomly around the target. So, okay, that is basically all about it. You may go through. Yeah, there are some other measurements, other instruments, stopwatch. How does it look like? Thermometer. What's the range of thermometer? Look at the range of it. Okay, the smallest or the sensitivity. How do you get the sensitivity of thermometer? Is important. And then ammeter, voltmeter. Also goes through the example. Then analyzing scientific investigation. You may go through it yourself and experiment. Then drawing a graph, getting the right scale, get the asymptote, the average for x and y value, helps you to gauge, to balance your graph. Before the end of this video, we are going to go through the last one actually, really the last one, which is called the analyzing graphs. Yeah, it's relatively important actually. So, if you have a graph, maybe it doesn't really matter what quantities they are, P and Q, but the graph look like this, a curve up. Okay, in your report writing, it will be, standard answer will be P increase, SQ increase, SQ increase. That's all. You can't really tell what's the relationship. It doesn't really tell, is it quadratic or exponential? It doesn't know. Yeah. Likewise, if the other way around, Q and P go down, then obviously this one straightforward, P decrease as Q increase. Yeah, look at the y value, this is 0. P decreases. Yeah, okay, going down, right? P decrease when Q increase. Refer to this one, Q increase going up as the P increase, sorry, Q increases. This is how it looks like, okay? And the other variant, maybe go through 6 of them, standard one in SPM. PQ. You need to really go through this, right? Okay, straight line. Like this. Obvious standard answer. P increase the keyword linearly. Now you need to have the word linearly. Linearly with Q. So that's the word. That's the keyword. P increases. Alright. P increases linearly with Q. It's a straight line. That's why I call linearly. Then P, Q. Now if you have going down, then that would be P decrease linearly with Q. This is the keyword linearly. Q or P decrease, depends on the graph going down. Yeah, from 0, it's always from 0. P go down, decreases linearly with Q. Because it doesn't start at 0, because you have a y-intercept. Now, what happens if you have y-intercept? You have graph that start from 0. P, Q, from 0. When 0 is 0, then it goes straight up. Okay, so this is direct proportional. Okay, so when the start is 0 and 0, direct proportional. So this is P is directly proportional. Direct proportional to Q. P direct proportional. You may use direct proportional if and only if it starts with 0. If you have an intersect, then it's just a linear. You can't say it is direct proportional. Okay, so that's how, and this is why people did so well in physics, because they will just know the way how to express them. Now there's another way where the quantity is no longer Q. Now it is 1 over Q, but yet it is a linear graph. Okay, it is direct proportional. There are two ways to express them. One tricky way would be, you may write P is actually inverse. Okay, inversely proportional. Proportional to Q. What happened? Because you look at this quantity here is 1 over Q. It's proportional to, inversely proportional to Q. Inversely proportional is linear. Inversely, why is it inverse? Because it's 1 over. 1 over meaning inversely proportional to Q. This is the keyword that you need to learn. This is how you need, this is a word, how you need to use it. Where do you need to use it? During report writing, or perhaps sometimes in paper 2. There are some other example in your reference textbook. I would advise you to read through it. You may rewind it to the earlier minute and go through what you have missed. But thumbs up rule is you stop or pause and you try those questions for 6 to 8 questions. Okay. For chapter 1, it's very easy. Yeah. And also try some past year questions. Okay. Every section, you may pause this video and go through at least 6 to 8. Yeah, at least 6. Yeah, maximum is maybe 8. It's very easy. Yeah, go through it, check the answer. If it's correct, then you proceed. That's how you do it. Right. That's all from me. I hope you press on the thumbs up button in my YouTube channel. It means you like my video, and I don't mind if you want to share with friends. And stay tuned to my blog. I have a blog, freethestuffforall.blogspot. You may check back from time to time, or for more video. That's all from me. Good luck in trying. Thank you.